Okay, so in this video we want to have a look at some problems involving surds. So often sort of Pythagoras measurement problems, we end up with surds and just looking at working with them in the context of other problems. So a quick review of Pythagoras' theorem. It's a rule that relates the three side lengths of any right-angled triangle, so only right-angled triangles. There's the right angle indicated there. In a right-angled triangle, the side length opposite the right angle is always the longest side length, and that's because the right angle is the biggest angle, so it opens out to the longest side, and that's called the hypotenuse. And then Pythagoras' theorem says that the square of the hypotenuse, so c squared in this case, is equal to the sum of the squares of the other two sides, so a squared plus b squared. Now, it doesn't matter what letters are what. I could label this, C and B and A. The important thing is that it's the hypotenuse squared on its own, and then the other two side lengths squared separately. So it doesn't matter whether it's called A, B, or C, or, you might call it H for hypotenuse and X and Y, or whatever. H squared equals X squared plus Y squared. The choice of letters is irrelevant. The fact that this length is the hypotenuse. That's the one that goes on its own. Okay. All right, let's have a look at some examples involving Pythagoras. So find the value of the pronumeral or pronumerals in each of the following, giving your answers in simplest surd form where appropriate. Okay, so in part A, this is our hypotenuse here. So x squared has to go on its own, and that's going to be equal to the sum of the other two side lengths squared, 10 squared plus 30 squared. 10 squared is 100. 30 squared is 900, because 3 squared is 9 and 10 squared is 100. 9 lots of 100. And so what we have there is 1,000. And so x is going to be the square root of 1,000, which is not in simplest form. The biggest square number that goes into 1,000 is 100. 1,000 is 100 times 10. And so therefore, simplifying the surd, it's root 100 times root 10, and we know root 100 is 10. So this is 10 root 10. Okay, and part B, again, this one's the hypotenuse, so that's got to be on its own. I always like to write the x on the left-hand side at the beginning, so this time I'm going to write my Pythagoras' theorem as 2x all squared plus root 5 all squared has to equal 15 squared. It's really important that you have these brackets here, okay? 2 times x squared is not the same as 2x all squared, so be clear about what you mean. In this case, it is this thing squared plus this thing squared is equal to this thing squared, okay? So if there needs to be brackets, then there needs to be brackets, and it's not correct without them. So 2x all squared is 4x squared, plus root 5 squared is 5. Root 5 times root 5 is root 25, which is 5. Or thinking about, if you take the number 5 and you square root it and then you square it, that square root and squared are just cancelling each other out to leave 5. Now 15 squared, I know that one, that's 225. Okay, so we've got 4x squared plus, let's subtract 5 from both sides. Sorry, so I'm not going to plus, it's going to be equal to 220. And so x squared is going to be 220 on 4. Now 200 on 4 is 50 and 20 on 4 is 5, so this would be 55. So x squared equals 55, and then x is the square root of 55. And we want to check that our surd is in simplest form. 4 doesn't go into 55, 9 doesn't go into 55, 16 doesn't go into 55, it goes into 48, so it doesn't go into 55. 25 goes into 50, but it doesn't go into 55. What's the next square number? 36 won't go into 55. It's 55 is really only going to be 5 times 11, and neither of those are square numbers, and so therefore we cannot simplify any further, and that is our answer. Just to be clear here, sorry, we've got some measurement problems here. So in part A there were units, so x was in centimetres, so that was in centimetres. Part B there's no units, so the length of x is just root 55. So looking at this example, it doesn't mean that that side length is root 55. This side length therefore would be 2 lots of root 55. And again, just thinking about, okay, well how big is root 55? Well, we know root 49 is 7. and root 64 is 8. And so this is sort of a bit closer to 7, so it's maybe sort of 7.3 or 7.4, something like that. Let's just check that out over here. So square root of 55. So you can approximate it in your head without needing to write an approximate answer down. You never write down an approximated answer unless the question tells you to give a rounded answer. So as I said, yeah, it's about 7.4, so therefore that length is 2 times that, so it's about 14.8. But that's an approximation. Its exact length is 2 root 55. Okay, let's have a look at some other examples where we might be working with surds. So find the exact side length of a square with area 500 centimetres squared. Okay, so a square has equal sides, okay, but we know that its area is 500 centimetres squared. And so area of a square is x times x. We know that has to equal 500, so we know x squared has to equal 500. And so therefore x must be the square root of 500, which is not in simplest form because 500 is 100 times 5 and 100 is a square number, and so that is 10 root 5. Now again, x was the side length of the square, the area, units of area were in centimetres squared, and so the length must be in centimetres. Alright, example 3. A rectangle has length 8 centimetres and width root 5 centimetres. Okay, so we're going to have 8 by root 5. Okay, remember root 5 is a bit more than root 4, so root 4 is 2, so it's 2 point something by 8. We want to find the area of the rectangle. Well, that's easy. Area is just going to be 8 times root 5, so 8 root 5. That's in simplest form. Find the length of the diagonal of the rectangle. So we want to find this length here of the diagonal. We could find this one here, but they'll be the same. So it's a right-angled triangle because we have a rectangle, and so we can use Pythagoras' theorem. So the length of the diagonal, let's call that x. We're going to have x squared, according to Pythagoras, hypotenuse squared equals sum of the other two lengths squared. So 8 squared is 64, root 5 squared is 5. So this is 69, and so x is root 69. Again, looking to simplify. Okay, 69 is 13, no, it's not even 13. I think it might be prime. Oh no, 3 definitely goes into it, sorry. Oh, it's not 30, it's 23 times 3. But yeah, 69 is 3 times 23. And then both of those are prime numbers, so they're not going to be able to be broken down any further. So that's the only factors, 1 times 69 or 3 times 23. And so therefore it can't be simplified because none of those are square numbers. We've got units here again, so area should be in centimetres squared. Diagonal length is a length, so that's going to be in centimetres. So again, you know, you can think about, well, root 64 would be 8 centimetres, so the diagonal length is a bit more than 8 centimetres. That makes sense given that this length here is 8, so it has to be bigger than 8. It has to be longer than 8 centimetres. But we wouldn't write it as a decimal answer unless the question specified. If we're just asked to find a length and not asked to give a rounded approximation of that length, then we would just leave it as root 69. It's the only exact way to write that number. Okay, example 4, determine the exact radius and diameter of a circle with an area of 125 centimetres squared. Okay, so we know for a circle, area is pi r squared. Oh, sorry, it's not a v, it's an r, pi r squared. In this case, we know that the area is 125 pi, and that's going to be equal to pi times r squared. So we want to solve this equation for r to find the radius. Once we've got the radius, we can double it to find the diameter. Dividing both sides by pi, 125 equals r squared. So r is the square root of 125. Now 125 is not in simplest surd form because 25 goes into that, which is a square number. It's 25 times 5, and so therefore it's 5 root 5 for the radius. So radius is 5 root 5, what units are we in? Centimetres again. And diameter will be double that. Sorry. Double that, 2 lots of 5 root 5 is 10 root 5. Example 5. The hypotenuse of a right-angled triangle has length 6 plus root 2. Another side has length 3 root 2 plus 2. Okay, so we've got a right-angled triangle. The hypotenuse is 6 root 2. And one of the other sides, doesn't matter, it's just a rough diagram to give me an idea, is 3 root, sorry, it's not 6 root 2, it's 6 plus root 2. And this length is 3 root 2 plus 2. Find the length of the third side. Okay, if we call that x, we can use Pythagoras. So we know that x squared plus 3 root 2 plus 2 squared has to equal 6 plus root 2 squared. Okay, I'm just going to move that off there and make it a bit smaller to give me a bit of room here. Okay, so we have x squared plus, we want to expand out this bracket. We want to use our perfect square expansion to do this efficiently. So remember, we've got our two things in our brackets. It's going to be something squared plus, because of the plus in the bracket, 2 times something plus something squared. And then we're going to have the same on the other side. Sorry, let me just, times yellow times blue, and that'll be blue. So in this case, that's 3 root 2, 2 times 3 root 2 times 2, and this will be 2. And on the other side, we're going to have the same thing happen. So if we've got, two things in our perfect square, again we've got plus, so it's going to be something squared plus 2 times something plus something squared. And again, it's going to be the first thing in the bracket that goes there, and the second thing in the bracket that goes there. So in this case, that's going to be 6 squared plus 2 times 6 times root 2 plus root 2 squared. Okay. Again, you might be able to do a bit of that in your head and not need to write it. You certainly don't need to be highlighting. I'm just trying to illustrate for you what's happening. So I'm using the fact here that a plus b all squared is a squared plus 2ab plus b squared. So that is that thing and that thing. That's the pattern we want to be able to see and use to make these expansions more efficient. So, be prepared to write out some ugly long lines while you just sort everything out and tidy things up. So we've got x squared plus 3 root 2 all squared is, 3 squared is 9 times root 2 squared is 2. This is 2 times 3 times 2, so 2 times 3 is 6 times 2 again, so it's 12 times root 2, and this is 4, so I might just simplify that, 9 times 2 straight away, that's 18. And then on the other side we've got 6 squared, which is 36, plus 2 times 6 times root 2, so that's 12 root 2, plus root 2 squared, which is 2. Let's just tidy things up a little bit more. 18 plus 4, so we've got 22 plus 12 root 2 equals 36 plus 2, so that's 38 plus 12 root 2. Okay, we can subtract 12 root 2 from both sides, and they're going to cancel out. I'm going to then subtract 22 from both sides. I'm going to have x squared equals 16. And so actually, very nicely here, x is the square root of 16, which is 4. Now, just to note, in these other examples, when I take the square root, you do need to think about the plus minus. But in this case, x, in all of these examples, x is a length or an area. So x must be bigger than 0. So that's why I'm choosing to ignore, the negative square root. Okay, so straight away I know that I'm only interested in the positive square root and so technically down the track we should really acknowledge why we ignored one of them, and we ignored it because x has to be a positive value because it's a length. And so we're finding the length of the third side, so therefore the third side is, it hasn't got any units actually, so it's just 4 units. Then we want to find the perimeter of the triangle, so we can just add up all the lengths. Okay, there's 3 lengths, 4 plus 6 plus root 2 plus 3 root 2 plus 2. So just collecting like surd terms there, 4 plus 6 plus 2 is 12, and root 2 plus 3 root 2 is 4 lots of root 2. And then again, we haven't got units here. You can just write units. If they were centimetres, you write centimetres. But once you put the units on, you really should put the whole thing in brackets, because it's not just 12 plus 4 root 2 centimetres, it is the units apply to the whole thing. Okay. However, we haven't got units here, so I'm just going to list the perimeter as 12 plus 4 root 2. So it's in simplest form, so everything's good. And then we want the area of the triangle. We know area is half times base times height. Our base length is going to be that, our height is going to be that. Obviously we could interchange them, it wouldn't matter, but it's half times x, which we know is 4 times 3 root 2 plus 2. So again, be a bit careful about brackets here. Area is going to be half times 3 root 2 plus 2 and times 4. Half times 4 is 2, so it's just 2 times 3 root 2 plus 2. And so expanding that out, that's 6 root 2 plus 4. Again, surd is already in simplest form, so everything is good there. But leaving our answers nice and exactly involving the surd, unless the question tells us to give an answer rounded to a particular level of accuracy. Okay, so there's a worksheet with an assortment of Pythagoras and measurement problems that involve or result in surds.